All right, 8.7 video notes. Law of sines. We have two sections left, 8.7 and 8.8. There's a law of sines and then there's a law of cosines. There won't be any law of tangents. But so two sections left, and let's kind of jump right into the law of sines here, which is pretty important because it allows us to solve triangles that are not right triangles. So just a little kind of quick review. I'm going to draw over here to the side, and you don't really have to draw this if you don't like to, but when you use SOHCAHTOA, all right, SOHCAHTOA, that can only be used with right triangles, all right, because when you set up your right triangle, you know, and you have a hypotenuse in there, okay, across from a 90-degree angle, this side has and always will be the hypotenuse. And the law of sines, that you don't have to worry about the hypotenuse because there isn't one. All of the triangles that we're going to try to solve today are not right triangles, which is kind of nice because not everything in the real world. But let's kind of break down the law of sines, and I'm going to draw a generic triangle over here, you know, something kind of like this, and it's not a right triangle. I'm going to label it angles A, B, and C. All right. Now, in order to understand how the law of sine works, you have to get the naming kind of mechanism down properly. So if this is angle A right here, shooting across from that little side, we're going to name that other side little a. And similarly, we're going to work across from B, and we're going to refer to this side as little b. And then across from angle C is side little c. All right, so A's across from A, B's across from B, C's across from C. Now, triangles can have other letters. If you notice, example 1 has an M and an N and a P. The big idea is you are related to who you are across from. All right, they kind of come in pairs. Now, what's going to be true, what the theorem or the actual rule that you're going to be using is that the sine of any angle, okay, so in this case, the sine of angle A over the side across from him, little a, has to equal the sine of another angle, B, in the side across from him, little b. So the big thing that you need to know for these problems are the angles go on top and the sides are on the bottom. All right, so angles are on the top, side lengths are on the bottom. And this is sine's the only one you're going to use. You don't have to worry about cosine or tangent or anything else. But now we have a proportion that when we set it up, we can go ahead and cross multiply, just like we've been doing, and come up with an equation that can be solved. Now, I didn't write it down, and I will now, but it's also true that the sine of C over little c, it can also be used. Now, you're never going to put all three of them together. You're going to basically choose 2 out of the 3 depending on what you are looking for. Now, when can you use this? I'll be honest, I don't have this memorized. I just always, if I see a triangle and it's not a right triangle, first thing I think of is, okay, I cannot use SOHCAHTOA. Second thing I do is I try the law of sines because it's easier. The law of cosines is a much nastier equation. It's tougher to deal with. So I don't really memorize these. But if you want, and if you get a cheat sheet, you actually could memorize that these 3 scenarios, basically 2 angles and a side in between, or 2 angles and a side, or SSA, you know, which I always refer to in class as ASS. But a double crooked letter there, also you can use the law of sines. I think this will make a little bit more sense once we start the examples, and you'll kind of get the feel of the flow of the setup. So let's go ahead and jump right into this. So the directions say for each triangle, find the indicated measurement. All right. Now, they didn't put an X, or they didn't put a, you know, a question mark or something, but number 1, it looks like we want to find NP. So find NP. So NP is this side here on the bottom, and it's across from big M. So this is we're going to call this little m. Little m is across from big M. Now, if you notice, first thing I'm going to do is I'm going to look for a pair of, I need an angle and a side across from him where I have both of them. So it looks like I have a pair right here where I have both of these. Notice I don't have big P or little p, so I'm not going to use P in this problem, but I'm going to use N's and M's. So here we go. The sine of 39 degrees divided by the side across from him must be equal to the sine of 88 degrees over, and now the letter that I'm looking for, little m. So really NP is just, we're calling it little m. So now I have a proportion that we can use to solve this. So let's go ahead and let's solve this. We cross multiply, and I have 22 times the sine of 88 degrees equals m times the sine of 39 degrees. So I now have an equation, my fractions are gone, and I have one step left to get m all by itself. I need to do the opposite of times by the sine of 39. So I'm going to divide by the sine of 39, and I'm going to divide by the sine of 39, and these two will cancel, and that should tell me what m equals. Now, I personally like to put parentheses around this before I hit the divide button. That's just me. Some calculators, you don't really have to do it, but I just like to do it. I think it's good practice. So when I do mine, I'm going to usually put those parentheses in like that. All right, so let's do this. 22 times the sine of 88 divided by the sine of 39. And it did a little bit of work, and then it looks like it is, I'm getting 34.9 about when I round this thing. Now I want to come back to my picture and see if that makes sense. Does it make sense that this side is 34.9? Well, I kind of go back to the old thing about, small angles are across from small sides, and bigger angles should be across from bigger sides. So I think that that's okay. I think that 34.9 seems legit. All right, let's go to the next problem here. So looking at this problem, I'm in a bit of a pickle. I noticed that I have the 67, but I don't have the side across from him. I notice I have 18, but I don't know what angle A is. And I notice I have 44, and I don't have a side across from him. So I don't have a pair. I really need to get a pair. But if I use a little bit of, chapter 1 geometry stuff, I can figure out what angle A is. I should be able to figure out how many degrees angle A is, because right now angle C is 44, angle B is 67, which that adds up to 111 degrees. So 180 subtract 111 should be 69 degrees. So even though they didn't give it to me, it wasn't too hard to calculate 69 degrees. Now I've got a pair. So now I have an angle with the side across. So let's write that down. The sine of 69 degrees across from side length of 18 should be equal to, and now I'm going to come another way. Well, who am I after? I'm after AC, which is this top side, which we're going to call that little b because it's across from big B. So that's the one that I need to set up. I need to then set up sine of 67 degrees over little b. And little b is going to be what I'm after. And now I cross multiply, and I get 18 times the sine of 67 degrees equals b, always start with your side, times the sine of 69 degrees. So now I've gotten rid of the two fractions, and I now have just an equation. And always in law of sines, to get b, I just divide both sides by the sine of 69. Divide by the sine of 69. And this will cancel, and we get little b, aka AC up here. Little b is 18 times the sine of 67 divided by the sine of 69. And I'm getting about 17.74. So always make sure you're doing this on the computer or on the calculator with me, just so you know the keystrokes. Okay, it's one thing to write it down, but it's another to be punching it in the computer as you go. And now I look up here and see if does that make sense. 17.7. Well, this side was 18. And those are really close, 18 and 17.7. But when I look across, 18 is across from an angle that is a little bit bigger. So that totally makes sense, and I think we're on the right path. All right, moving on down. Now, one thing I want to show, though, actually, before I move on down, I want you to kind of see a pattern developing that you're pretty much always going to multiply the two that you have both, and then you're going to divide. You're going to always divide by the thing that's across from your variable, the one that you're looking for. If you notice on this first problem, I divided by the sine of 39 degrees, and notice that was the one that was across from the variable. So you're always going to divide by the number that's across from the variable, and that's a little shortcut that you can use once you get better with this. So I'm going to kind of use the shortcut here on these last couple. And I look at this one, oh man, the game's changed. I'm not looking for a side. I'm actually looking for an angle. So let's kind of see what's going to go down here. Normally when we're looking for an angle, that typically tells me that I'm going to have to use the inverse. I'm going to have to use the -1 stuff here in a second. All right, so let's see what's going down. Well, I have a pair. I have an angle and the side opposite. So I'm going to start this thing out. The sine of 50 degrees over 7.6. Now, I want angle X. So angle X is what I need. And across from him is a side of 4.3. So now my X is in a little bit different position. It's the sine of I don't know over 4.3. So this is different than the top two problems because I need to figure out what the angle is and not what the side is. So my X kind of jumped up to the top here. So let's go ahead and let's cross multiply. And I get 7.6 times the sine of x degrees times sine of x degrees equals 4.3 times the sine of 50 degrees. Well, on the last few problems, I could just divide by a number and divide by a number, and I was all set. This one I think is going to be a couple steps for me. First thing I need to do is get the sine of x all by itself. So I'm going to divide this side by 7.6. And I'm going to divide this side by 7.6. These are going to cancel. And now I'm not going to get x, but I'm going to get the sine of x equals. And now let's go ahead and let's punch all that in. I'm going to punch in 4.3 times the sine of 50 equals divided by 7.6, and I'm getting 0.4334199. Now this looks like a problem back in 8.5 where, remember, we now know the ratio and we need to go backwards and figure out the angle. So this is where I need to do the inverse. So basically right now I'm going to take the inverse of both sides, and that should tell me what x is. So let's take the inverse sine of all this stuff. Now, there's two ways to do this. I could punch in inverse sine and then type all those decimals in. But since this is already in my calculator, I'm going to do this little move. I'm going to do second. I'm going to hit the second key, and then I'm going to hit sine, because that gives me my inverse. And now instead of putting that number in here, on my calculator, where there's the little negative key on the very bottom, right underneath the 3, right above that says ANS. And that will take your previous answer and plug it back in for you, so you don't have to retype the whole thing in. Now, in order to access this little ANS at the top, you do have to hit second again. So second sine basically gives me the inverse, and second that says, hey, what's the inverse of the last answer? So I'm going to do that. I'm going to go second sine, second answer. And my calculator actually says this to me. It says sine -1 parentheses ANS. If it says that, you did it right. And then when I hit equals, I get an answer of 25.684, some other stuff. So rounding the nearest tenth, this would be 25.7. And that's degrees. So maybe I'll just call it 26 degrees if it says go to the nearest tenth. Either one, X over here is roughly about 26 degrees. And that makes sense because it's across from a small side, 4.3. 50 is bigger and it's across from a bigger side, 7.6. So I feel pretty confident that I did that right. So finding the angle is a little bit more difficult. Now I did a lot of explaining in that one, so maybe on this next one I'll be able to go a little bit quicker and it won't seem quite as daunting. Alright, so we need to figure out the measure of angle L. So we got to figure out L. Now we do have the side across from L, 6. So the sine of L over the side across equals, and now I have the sine of 125 across from 10. And I set this thing up and I kind of do a little 6 times the sine of 125 equals 10 times the sine of L. I got to get the sine of L by itself. So I'm going to divide by 10 and divide by 10. And I get the sine of some degrees is, and let's do this decimal over here, 6 times sine 125 equals, divided by 10 equals, I'm getting 0.491491 So I'm now just going to do the inverse sine of that thing, which in my calculator I'm going to have it just use the previous answer. So second sine, second negative key, and equals, and I'm getting about 29.4. Now as always, I go back in, I plop it into my picture and see if that makes sense. So L 29.4 degrees, and I guess that looks okay. It looks like a pretty small angle according to the picture. It's across from 6, the 125 is across from 10, so I think I'm in pretty decent shape. So law of sines can be used to find sides, it can be used to find angles. Angles requires a little extra step at the end where you have to do the inverse. So make sure to pay attention to that. I do want to point out that it is possible to not even do SOHCAHTOA on a lot of problems, because you could also use the law of sines. So if I go back to a problem here and I have the 90, and let's say this is 14, and let's say this is, I don't know, I'm just making something up here, 50 degrees, and I'm like, hey, let's find out what x is. You now have two different ways to solve it. Using SOHCAHTOA, using right triangle trig, I would put my guy, right here, and I would say, hey man, this is the opposite side, this is the hypotenuse, so I'm going to use the sine of 50 degrees is opposite over hypotenuse, and multiplying both sides by 14, I get x is 14 times the sine of 50. I'm not going to worry about whatever that answer is, but that's that. Now, if I wanted to, and let's say you get to the test and you just kind of freeze, but you do remember the law of sines, you could use that as well. Okay, not 19, it should be 14. Because watch what happens. When I come through and I solve this thing, I could now pair people up and say 50 and x, so the sine of 50 over x, and then come the other way, the sine of 90 over 14, and then you can cross multiply and get x times the sine of 90 equals 14 times the sine of 50, and then divide both sides by the sine of 90, which the sine of 90 just turns out to be 1. Basically, you're just dividing by 1, and what you end up with is the exact same answer, because sine of 90 is just 1. So you still get 14 times the sine of 50. Either way, when you crank that out and you punch it all into your calculator, you would get 14 sine 50, about 10.7 in both scenarios. So I do want to point out the law of sines can be used on a lot of right triangle problems as long as you can line up people who are across from each other. But the key idea is on all these problems, any triangle that you happen to have, when you play this little across from game, okay, you must know 3 out of the 4 pieces. You got to have 3 out of 4, meaning only 1 unknown piece. Otherwise, it can't be solved. All right, well, this should be enough to get you rolling on the 8.7 practice. You have officially learned or started to learn the law of sines. See you.